So we're going to continue talking about the concept of using scientific methodology and scientific research methods and scientific statistics to address the questions of human behavior, which is at the heart of psychology. Why do psychologists act the way they do? And so the first thing we're going to talk about is kind of the canons of scientific experimentation. And canons basically are a way to think of canons are basically the foundation or the basis from which we're going to move forward. In other words, all attempts to know the world have to start somewhere, and they start with assumptions. And these are effectively assumptions, and they're the assumptions that we hold as truths, even while we recognize that they are just one of many assumptions we could start with. So the assumptions or canons of scientific experimentation are the following. First, we have the assumption or the canon of determinism, that all events have a meaningful and systematic cause. So science does not outright reject the supernatural, but it does basically state that any event has to have a meaning and systematical cause, and that is where we're going to start our basis. In other words, our assumption is that we live in a deterministic universe. All events have meaningful and systematic causes. Things don't just occur. Things occur for a set of reasons. Now, what those reasons are is open game, and maybe those reasons are things that might at some point have been thought to be supernatural. In fact, a lot of our understanding of chemistry and physics were the concepts of magic thousands of years ago. So, but what it does say is there is no such thing as simply saying it's magic or it's supernatural. If that is the answer, then the question becomes, how does magic work? How does the supernatural work? Because we're also going to assume that it's deterministic, that even within that framework, there is meaningful systematic causes. Now, is determinism the way the universe works? We really don't know, and we probably will never completely know. But has determinism resulted in almost all of our scientific advancements? Yes. Determinism is the basis and the foothold, if you will, the starting point of almost every major discovery, resulting in the simplest of sciences, such as making bronze into better metals, all the way up to starting again with the creation of fire, the domestication of animals, all the way up to the cell phones that probably every one of you have in your pocket or near you right now, hopefully not currently on it while you watch this video on another device. Our second canon or assumption is empiricism, that the best way to learn about a deterministic universe is through observation. In other words, if we really want to learn what is the meaningful systematic causes, the best way is to not do intuition, not do superstition, not do authoritarianism or tenacity, but to make observations and to make systematic, purposeful observations to truly figure out what's going on. The next one is parsimony, that if you have multiple answers, multiple potential reasons or causes to the observations you're making, always go with the simplest. In other words, the simplest method or the simplest answer is generally the best answer. That a complex answer is only better if it truly gives you more information. And within human behavior, this becomes a little bit of a slippery slope, because parsimony often becomes, yes, we could give you a better answer, but the amount of increase in prediction is so small for the increase in complexity. A good example of this is a lot of psychological theories are fairly straightforward and basically are, in this situation, most people will behave this way. And what's based there is the idea that 70+% of people will behave as predicted in that situation. That's a simple, parsimonious statement. Now, could we get better? Oh, we could. If we measured personality and cognitive experiences and level of development and all of these other factors, whether the person had a good night's sleep the night before, what their past behaviors were, all of that would give us a better prediction. We might get that from 70% likely how you're going to behave up to 80 or 90%. But we'd have to do that for every single person. So it's not necessarily that the simplest is always the best, but what we are looking for is relatively simple explanations of human behavior that will give us the biggest, if you will, bang for our buck. In other words, they'll work in most situations, they're easy to understand, and they're easy to apply. And that's a big part of parsimony too, is how do we make sure that our theories are actually usable? So we might be able to get to much better prediction of human behavior with a lot more information, but do we have the time, resources, and is it worthwhile to do that for every single person? And that's also a pretty big difference between individual therapy, where you do have hours and hours of individual sessions where people are learning as much as they can about the problem, versus kind of interventions in a workplace where we're creating a new program which we're hoping most people will actually work better with them. So again, parsimony is simply not just that simplest is best, but what is a way to take the ideas of determinism and empiricism and word them in such a way that they're actually usable in day-to-day life. And finally, and this is a big one, all of our theories should be testable or falsifiable. In other words, if we believe in a deterministic universe, if we're using empiricism to create observations, then those observations we're making should not be stacked, if you will, to where the only result could be approving our theory. A lot of early theories in psychology actually failed the testability, and it was one of the reasons some of the other sciences actually kind of dismissed psychology initially. That it seemed like there was a lot of theories that were all about internal or unconscious drives. Well, how do you test an unconscious drive? You really can't directly. So basically, that's the final thing, is that if we're in a deterministic universe, if we're going to learn about that universe through empiricism, if we're going to try to make sure that as we make these observations, we're looking for simple and easy to understand and easy to act on theories, those theories also should be testable to where they can either be proven or disproven by our observations. So then we move forward to the criteria of scientific methodology. And this is kind of a different way to look at those other four. Those first four that we dealt with in the last slide are kind of our assumptions or our canons, and in many ways, they're kind of living broadly in the land of theory. They're what we're thinking about when we're creating psychological theories. Can it be testable? Is it observational? Is it based on a causal relationship? And is it relatively simple, or as simple as it can be? Once we actually move into creating the study and doing the study in the land of not theory but observation, we then need to make sure that every one of our studies follows the following methodology. We need to make sure that the variables we're interested in can be tangibly collected. We can measure, we can observe in some way, maybe inferred, but we can observe what the interest, what our cognitive or constructs of interest in psychology are. Can they be measured? Can we objectively come up with a measure that people can agree on that is standardized in such a way that every person that's in the study or every behavior that we're watching is measured effectively the same way? Can our theory be proven wrong? Is it falsifiable? In other words, once we start the observations and we're objectively measuring the variables, have we set up a study to where if we find what we're looking for, it proves the theory, or at least supports that theory, but if it doesn't come out the way we expect, it disproves or at least calls the theory into question. And you'll notice that psychology and sciences in general tend to be a little careful around the word prove. We usually words like support or did not support. In other words, we're kind of saying that to prove a theory is effectively saying the theory it's becoming tenacious. It's becoming something that can't be questioned. We're more saying generally with falsifiable that our theory is supported or not supported by our findings. And finally, can your study be repeated? We can have a study that is observable with objective measures and even falsifiable, but if it can only ever occur once and we can never do it again, that means that no one else can test it. So any study that is scientific needs to also be repeatable. Other people could read your study and do it for themselves and put it to the test themselves to find out if they agree, and whether or not what you found was found again in other studies. So when we're conducting actual scientific research, another question we have to ask is just the reality of the real world. Is the study feasible? And this is the trade-off between rigor and practicality. When we talk about rigor, what we're talking about is, have you taken into account every possible construct, every possible confound every variable possible, have you created a study that cannot be questioned? That if you find the results you're planning to find, it is, without question, a rigorous enough study that no one could find fault with it. Getting to rigor takes a lot of time, a lot of practice, a lot of thinking, and often a lot of resources. A lot of times we have to do what is practical. So for example, if I was wanting to look at human behavior in general, and what I was wanting to make a statement about was the impact of study guides on test performance. A study I might do is I might take a class that I have already teaching with 70 students in it, assign 35 of those students randomly to get a study guide, and the other 35 to not get a study guide. I then give them the test a week later, and I see, do the people with the study guide do better than the people without? If so, I could say the introduction of study guides seem to support the positive performance on a test. But what are some of the problems with this test? So let's start looking at it from a point of rigor, not practicality. Well, first, I had a convenience sample. I had students that were in a college class, so that ties it to those students. What was their age range? Might have been 20 to 25. So that's a very small snapshot of humanity in general. Also, it was people that could afford to go to college. It was people that were in Illinois or Missouri, most likely, and near St. Louis. So we're seeing all these limitations in my findings. Also, what did the study guide look like? How much information was on that study guide? What kind of study guide was it? How motivated were the people that got the study guide? Was there a difference between them and those that did not get that study guide? Also, for the students that didn't get the study guide, did any of them just wander over to someone that did and say, hey, can I get a copy? So there's a lot of questions that could come up that would question whether or not my study was truly rigorous. If I really wanted to say study guides increase test performance in people in general, what I'd probably have to do is randomly grab people from all age ranges, all education levels, and all geographical regions from the world. I would need to do studies all across the country, all across the world, in other countries. I would need to be looking at preschool. I would need to be looking at college age, high school, people of retired, people of working age, and I'd also need to look at different types of study guides. I could put that all together, and if I did find that across all ages, all geographical regions, all types of people, all types of study guides, those with study guides always did better on tests no matter what they were studying, that would be an incredibly rigorous study. But it would also be immensely time-consuming and immensely expensive, and it wouldn't have any practicality. So when we're creating a research study, not only are we wanting to think about the last two slides, we're wanting to think about what is the theory we're testing, is it observable, is it deterministic? We want to think about the actual criteria for scientific methodology. Is it observable? Is it systematically observable? Is it falsifiable? And then we want to ask about how much rigor can we feasibly do? And again, it's rigor versus practicality. The more practical it is, probably the less rigor. The more rigorous, probably the less practical. And some of the things we want to think about is how long will it take? How much resources? How much access do I need? Are there any ethical constraints with what I'm doing? How much cooperation do I need from the participants? And overall, what are going to be the costs? And a lot of experiments are less rigorous because we want to be more practical. We have constraints on what we can do ethically. We have constraints on how much cooperation we need from our participants. We have constraints on how much time we have to run the study and how much money we have to spend on the study, how many people we have to help with that study. It's one of the reasons that science is often, specifically in psychology, is the science of replication. A lot of times when someone finds an effect, other people will do additional studies looking for that same effect under different conditions with different people. So how do we avoid some of these pitfalls and make sure what we're doing is what we actually should be doing? One of the places that we really do need to start is the lit review. So a lot of times students look at the lit review as unfortunately busy work, but honestly the lit review is the foundation that any study is built on. It's a review of the scientific literature, and we want to do this review fairly early on, often even before we've necessarily come up with direct research questions. We might have some hypotheses and some thoughts in our head, but we actually want to avoid writing down our specific research statements or hypotheses until after we've conducted a lit review. The review can help us in many ways. It can help us to see if our ideas have been tried before. We might, for example, think we have a really cool idea, and the second we start a lit review, we find out hundreds of people have done this study already. It allows us to include all relevant constructs. So we might actually realize that we have a decent idea, but other people have already looked at it and found that what we really should be looking at is XYZ. So for instance, we might be looking at gender differences in spatial perception. And that's a good example of something that is pretty well established in the literature. There has been basically findings that find that men tend to be better at spatial perception tasks than women. However, that gender question of the idea that it's men versus women, more recent studies have found what really matters is what toys you played with as a kid. Regardless of whether you're male or female, if you primarily played with building toys, Legos, and construction kind of concepts, you have good spatial perception skills. And if what you mainly played with as a child, regardless if you were male or female at birth, is whether or not whether you played with kind of more dolls in social situations, you probably have less success with spatial perceptions as an adult. So this is an example of a relevant construct, that though the research was showing there was a gender difference, there's a better question to ask. Not what your gender is, but what toys did you play with? It can also help you with how other people have operationalized your ideas. It can help you select instruments. It can help you actually kind of design the study that you're going to do. And it can also help you anticipate common problems. So it's not necessarily that we're always going to start with no idea at all with a lit review. But once we have the basic idea, I'm interested in the following constructs. The scientific lit review helps us establish where does our study fit in the greater literature that already has come before it. How are we adding to it? And also, how are we building on it? How are we using past studies to understand how to do ours better? So again, we come back to that idea that we start with a theory. It's what we think. We have a causal construct that we're interested in, and we have a cause and effect relationship with an effect construct. So we have basically something we believe is going to affect human behavior and some way to measure human behavior. And from that theory, we're going to do our lit review. We're going to look at past research. We're going to look at people that have already looked at this or similar ideas. We're going to see how did they operationalize their cause constructs, how did they operationalize their effect constructs, and what did they find, and are there things that we need to incorporate in our study to make it better? After that lit review, we're going to create our study, the program of what we do to what we see. In other words, how do we manipulate the cause construct? How do we look for the relationship between that cause construct, and how do we observe the outcome in human behavior, what we see? So basically, the observation is what do we do, how do we test it, what do we observe, and how does that affect our understanding of in this study? So in the land of theory, it's our thoughts, it's our lit review, it's our statements that we're going to test. In our observations, it's the specific study, the operationalized study, that we're going to actually put these ideas to the test. So just recognize in general that when we talk about research methods, we're mainly going to be focusing on prediction and explanation. However, research methods include all three: descriptive studies, predictive studies, and explanative studies. So description, prediction, and explanation. Descriptive studies aren't actually looking for causal relationships. They're just trying to define the constructs themselves. They're observations, they're case studies, they're surveys. They're describing one particular construct. So for example, a descriptive study would be the first study that kind of found that personality tends to be 5 major factors. If any of you have heard of the idea of the big 5 personality factors, often referred to as OCEAN. So we've got, now I'm calling myself out on my own. I'm not a personality psychologist. But we have extroversion, we have agreeableness, we have narcissism, then we have openness to experience, and we have conscientiousness. There we go, I called it up. Those weren't hypotheses where we're testing particularly a causal relationship between variables. That was just trying to basically find a way to talk about personality in a parsimonious or more simple way. Prior to the development of the Big 5 personality model, personality measurements there were hundreds of them, hundreds of different subconstructs of personality, and it wasn't a very parsimonious theory. Now, does the Big 5 theory capture all differences in personality? Absolutely not. but does it capture most of them? And is it capture the big ones that tend to actually affect how we behave? Generally speaking, yes. So that would be an example of a description study. Prediction studies are just looking for patterns. They're looking to describe and predict behavior, but they're not necessarily looking for the cause of behavior. These include most correlational studies and quasi-experimental studies. Basically, they can find a pattern, but they may be finding a pattern that has a better solution. And I'm going to go back to my example of gender and spatial perception. That was a correlational study. It looked at the differences between men and women and how they actually behaved in spatial perception tasks, and a lot of those studies were done in the 50s, 60s, and 70s. However, though they found a relationship, and a pretty solid relationship, that allowed you to predict some behavior and described that relationship, it turned out that there was a better description. There was the description of basically what kind of play or development had you gone through prior to reaching adulthood and then doing these spatial perception tasks. So that's an example of a predictive study. And this class, by the way, Psych 220, is mainly going to focus on correlational or predictive, not necessarily causal. The final type of research methodology is explanation. It is experimental methodology. It is both description, prediction, but adding cause of behavior. And notice these are additive. Predictive studies cannot move forward without a descriptive study. Unless you actually have already described the construct you're interested in, if you know how to observe them, if you can describe them, how can you look for relationships between them? So description starts first. Once we know how to describe a variable, we can do predictive studies with correlation. And if we find that relationship, our next step would be to set up true experimental methodology to basically rule out any other potential cause of that behavior. And those are causal studies, and we'll be talking more about causal studies and cause and effect or true experiments in Psych 221. So broadly speaking, kind of coming out from this what is science, the biggest thing to kind of recognize is the philosophy of science, what and how we can know, basically breaks into two major things: epistemology and methodology. Epistemology is a branch of philosophy that studies the nature of knowledge. What are our assumptions, and are those assumptions valid? So when we're talking about determinism, when we're talking about empiricism, when we're talking about rationalism, all these terms that I've defined and talked about so far in this lecture, we're talking about epistemology. We're basically saying and recognizing we are starting from a set of assumptions, and we believe those assumptions are true and valid. Methodology, which is what we're mainly going to focus on from this point on in this class, is the practices and procedures and rules used in that epistemology. So the epistemology is scientific integrity, scientific methodology, scientific inquiry. And now we're going to focus beyond that assumption that those are indeed a valid way to look at the world to what methods do we do if we are using the epistemology of scientific inquiry.